Okay, as I said in the last video, that in the next video I'll be discussing the practice set 1.1 of the set theory. Before starting the exercise, let's see few examples so that the definition of a set will be clear. Okay, to get a clarity over the definition, I have wrote few examples and let's make out which is a set and which is not a set. So if you observe days of a week, this will form a set because the elements of the set of the collection is well defined. Days of a week. Next, brave children in the class. This will not form a set. Okay, first 10 counting numbers. This will definitely form the set because anybody who makes the set, they will come out with the same elements. Again, months in a year will definitely form a set. Strong forts of Maharashtra will not form a set because here they are talking about the strength of the forts. Okay, that is not a clear idea. Planets in a solar system again will form a set. So if you observe, when we have some abstract quality or what's the adjective added to the elements of the collection, that doesn't form, it's a relative term and doesn't form a set because the elements of these two collections are not well defined. They are abstractly given some qualities of being strong or being brave. Okay, now we can get into the exercise of that or the practice set 1.1. Okay, now let's start with the practice set 1.1. The first question is, write the following sets in roster form. I have shortly written the question. Okay, so the first is even numbers. The set of even numbers we have to write in roster form or listing form. Okay, so let's name the set using the letter E. Okay, now I have to list the even numbers. So what are the even numbers? 0, 2, 4, 6, 8, and then it continues. It is an infinite set, right? And let's get to the next sub question. Even prime numbers from 1 to 50. So I will name the set using letter P. Now I have to list all even prime numbers from 1 to 50. Which is the only even prime number that exists? It is 2. Alright. Why is that so? Because if you observe, 2 is an even number and it is also prime because it has only one acids divisor other than itself. But any other even number greater than 2 will have two acids divisor. It has a divisor other than itself and 1. So any other prime number greater than 2 is not prime. Any other even number which is greater than 2 is not prime. Only 2 is prime and 0 is not considered over here because we are talking about prime numbers. Okay. So this particular set has only one element. Next, negative integers. So I will denote or I will name the set using letter N. Okay, you can give any letter. I just gave it in randomly. Negative integers means okay, -1, -2, -3, -4 and goes on. Alright. Again, this is an infinite set. Infinite set in the sense there are innumerable elements. So I can name only few of them. Next is 7 basic sounds of a sargam. So I will write it over here. Let's name it as S. I'm just listing all the 7 basic sounds. Sa, Ri, Ga, Ma, Pa, dha, ni. 1, 2, 3, 4, 5, 6, 7. Alright, so we are done with the first question. The question was writing the sets in roster or list form. Even numbers, even prime number, negative integer, and 7 basic sounds of a sargam. Now we will do the next question. And the question says, write the following symbolic statements in words. So they have given a symbolic statement. I have to convert it into words. So as we discussed in the last video, 4 by 3, this symbol means belongs to or is an element of. So 4 by 3 belongs to the set capital Q, or 4 by 3 is an element of the set capital Q. So in words we have to write it as 4 by 3 is an element of the set capital Q. Simple. Now the second one is -2 does not belongs to capital N, or -2 is not an element of the set capital N. -2 is not an element of the set N. Okay. Now third one is P. Okay, they have given a set P and they have represented it using rule method. P is an odd number. Now I need to write it in words. So to be precise, one way to write it is I can just say that capital P is a set of odd numbers. But we have to be precise and we need to write every detail. We need to convert every detailing. So we will write it as P is set of all such small p's such that all small p's, I don't write such here, p's such that P is an odd number. P is an odd number. So P is a set of p's such that given P is an odd number. Okay. So now we are done with the second question. Now we will get into the third question. Okay. Our question 3 says, write any two sets by listing method and by rule method. Actually, this is a simple question. We have discussed many examples. Any example we can use here. So, let's write set of vowels. Alright. So using, first I have to use the listing method, that is a roster method. So I have to list all the vowels. A, E, I, O, U. And how do I write it using rule method? I will use a general term for the elements of the set and then I will write the rule that term has to follow. Given X is a vowel. Okay, so this is one example. Another example. Set of even numbers from 1 to 10. Okay, so how that will look like? E, using roster method I can write it as 2, 4, 6, 8. And using rule method is n such that n is an not integer, let's make it, so is an even number and one less than equal to n less than equal to 10. That is a restriction because we want n to be between 1 and 10. Okay. Or simply we can write it as, if we want completely in word, n is an even number from 1 to 10. Okay, so we have two sets. Now we will discuss the fourth question. Now I have chosen only 3 sums from these questions because same type question we had done in the question number 1, in which we wrote the roster form. So here I have done only 3 examples, rest you have to do it on your own. Please ask any of your doubts in the comment section. Okay, the first question is the letters of the word complement. So we have to just name it as L. Just list the letters used in this word. C, O, M, P, L, E. Now M already I have mentioned, so I can't repeat it. E also I have already covered. Next is N and finally T. So here only the rule is I should not repeat any of the elements. Okay. Now third one is set of human sensory organs. Okay, this is also simple. I will name it as H. Which are the human sensory organs? I have to just list it out. Ear, eyes, nose, tongue, and finally skin. 5 sensory organs. Okay. And the next question is prime numbers of 1 to 20. That means lying between 1 to 20. Prime numbers means it should have only 1 and itself as first is 2, 3. 1 is neither prime nor composite. Okay. So 2, 3 and then 4 is not, 4 is composite, 5 is prime, 6 is composite, 7 is prime, 11, 13, 17 and 19 because it should be less than 20. Okay, so these are the prime numbers lying between 1 and 20. Okay, so we are done with the question number 4. 2 questions, more questions are there, but that you are expected to solve by yourself, and please ask any of the doubts in the comment section. Okay, now let's discuss the question number 5, that is write the following sets using rule method or set builder method. Okay, this they have given a list of elements 1, 4, 9, 16, 25, 36 and so on. Okay, now I have to express this set using rule method. That means I have to use a general term for denoting the elements, and then I have to write what rule this particular term has to follow so that it will be an element of this particular set. So if you observe, what is the relation between these elements? Relation as such, it follows a common rule. What is it? If you observe, this is 1 square and this is 2 square, this is 3 square, this is 4 square and this is 5 square and so on. So we have all perfect squares written over here, and it is ranging from 1 to 10 because 100 is 10 square. So my n is equal to m square, and m belongs to natural numbers and m is less than equal to 10. So m is a natural number, so it will start with 1, and m is less than equal to 10, and it will stop at 10. So when m is 1, n is 1. When m is 2, n is 2 square, that is 4. When m is 3, n is 9, that is 3 square equal to 9. And similarly till 100 we will obtain all the elements. Okay. So simple. Now next. Now similarly I will use a letter to denote the elements, and I will write the rule that this letter has to follow. Now here the pattern is much more simple. Actually it is just multiples of 6. 6 ones are 6, 6 twos are 12, 6 threes are 18, 6 fours are 24, and similarly till 48, that is 6 eights are 48. So x is equal to 6 times y, and y is natural number again, and till where I need y to be less than equal to 8. So when y is natural number, so it will start with 1. So when y is 1, x is 6. When y is 2, x is 12. When y is 3, 6 into 3, 80. When y is 4, 6 into 4, 24. 6 into 5, 30. 6 into 6, 36. 6 into 7, 42. And finally till 8 I can reach, so 6 into 8 is 48. So I get all the elements back. Clear? So now the next question in this particular exercise is, that is the third question, is this is very simple. So how do we write it in rule method? I will denote it using x is equal to a, such that a is a letter in the word. Which is the word formed using these letters? Smile. Okay. The next question is, they have given all days of the week. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. I am not writing all the days, but they have given it like this. Okay, all they have listed all the days of a week, and now I have to write it using rule method. So it is x, the set of all such x's, that x is day of a week. Simple. Now one more question is, actually this is that question is also very simple, but still I will discuss it. It is saying a set with 3 letters. Okay, so what words can be formed using these 3 letters? One is, we can say 8. I ate an apple, right? Or it may be tea. Okay, so sometimes we can form more than one word. Any word you can use in rule method to represent it. So E is set of all such x's, that x is a letter in the word okay, T. I will use the word T. Simple. So we are done with the practice set 1.1. Okay, so after the first two videos, we have a clear idea about the definition of a set. Definition of a set. Secondly, we learned notations. What were the notations? Belongs to and does not belongs to. And next we learned the methods of writing a set. Writing a set. And which were the methods? Roster method. Roster means listing. And second one was rule method. Rule or set builder method. Set builder method. And next which we learned was definition, notation, method. Okay. And then we have a clear idea about some fundamental sets and their notation. Fundamental set of numbers. Which were they? Set of natural numbers, set of whole numbers, set of integers, set of rational numbers, and set of real numbers. So these are fundamental notations and few important set of numbers that we have already learned before. Okay. So, and I hope that you got a clear idea about all this concept when we did the practice set in this video. Thank you. Stay tuned for the rest of the chapter.